never had a student want to do a lesson on a Friday. But that's true for every other day of the week too. So, all right, here we go. It says to solve by factoring. So you really want 0 to be on the right side of the equation. You got that, check. And then you look for the different cases. So for this one, it's an a equals 1. There's a 1 in front of x squared. You look at that last number, negative 56, two numbers that multiply to negative 56, but add to negative 1. That means they're like 1 apart without the sign. So I don't know if that helps you to think what those two numbers might be. How are you doing on that list there?
Pretty good. Is it 7 times 8 that
Yes.
is?
Yeah, and that's what I meant
Okay.
by like they're 1 apart. Now we've talked about for a long time, like one's positive, one's negative, but they're 1 apart. That's how you get to negative 1. So is it negative 7 and 8 or 7 and negative 8?
7 and negative 8.
Good. So this becomes x plus 7, x minus 8 equals 0. You set them both terms now, both terms equal to 0. X plus 7 equals 0. X minus 8 equals 0. What are your two answers for x?
X equals negative 7 and x equals 8.
Good. All right, let's do 3 next. We'll come back to 2. 3 is more like number 1. So you do have to get everything on one side of the equation. In this problem, we're going to add x squared to both sides. And that gets you a positive x squared. You really want x squared to be positive. It's easier to factor. You can do negatives. We've never done any by choice. It's much better not to. But same thing here. Two numbers that multiply to minus 36, add to minus 5. Will you give me those numbers, please?
Sure.
One's positive, one's negative.
This shouldn't be taking me this long. Sorry.
That's okay. If I tell you the answer, it doesn't help either. So just keep doing what you're doing there. It's okay to guess. You don't have to go in order. I may have given you the impression that you have to do it in a certain order. You just have to get the answer. However you see fit. So
4 and -9.
Yes, very good. So x plus 4, x minus 9 equals 0. You set them both equal to 0. Give me those x values whenever you got them, please.
All right. X equals -4 and x equals 9.
Good. Great. All right, let's look at number 2. 4x squared minus 32x equals 0. It kind of looks like the last one because it's got an x squared, but there's only 2 terms. They both have an x in it. This is a GCF factoring. So between 4 and 32, what is the GCF? What's the biggest number that goes into both?
4.
4.
X.
And then the x goes with it. So you divide both of those by 4x. And that's x minus 8 equals 0. And you set both of them equal to 0. 4x equal to 0. X minus 8 equal to 0. On the left, you divide by 4. On the right, you add 8. Should get x equals 0 and x equals 8.
Yeah.
Any questions on that before we move on to like 4, 5, and 6, which are different?
No.
All right, number 4 here. So the difference here is in all these problems, there's only one x. There's only one x here. There's not, and it's an x squared. So you treat this like you want to solve for x squared by itself. So you add 21 to both sides. 4x squared equals 36. Divide by 4, divide by 4. X squared equals 9. Can you tell me from here what to do or what this becomes?
You gotta find the square root of both sides. And
Yes.
3.
Anything else?
Oh wait, would be positive or -3.
Yes. Yes. It's
because
really,
of-
yeah, it's really plus or minus the square root or plus or minus 3. Okay. And that's really important, especially for the next one. There's always 2 solutions. You got to find both of them. All right, number 5, you ready for that?
Yeah.
Okay. Number 5 here. So we got kind of a similar situation. You do take the square root of both sides. So what do you get on the right side? What does the square root of 16 become?
Positive or -4.
Good. And the left, it's x minus 5. And this is where it's 2 cases, kind of 2 forks. You got the positive one, x minus 5 equals positive 4, x minus 5 equals -4.
So it's x equals 1 and x equals 9.
Great, really good. All right, let's go to number 6. All right, so this is kind of like number 4. You're going to divide both sides by -9. X squared equals -9. Okay, this should look like a problem. You should say, ah, there's something that doesn't look right here. Can you take the square root of a negative?
No.
No. No, we talked about this idea that the square root of negative 1 is I, but in the real domain, you can't do this. But do you remember if you were doing this I stuff or not?
Yeah.
Okay. So we do have to take a square root of both sides. Plus or minus the square root of negative 9. That becomes plus or minus the square root of negative 1 times the square root of 9. And that's where this negative 1 is I, and 9 is 3. So this comes together to be plus or minus 3i. Is that okay? Kind of?
Yeah.
All right. Number 8. We're gonna go to number 8. We're gonna skip 7. We'll come back to it in a moment. 8's kind of more in line with what we've been doing. The property here is that the square root of a over b becomes the square root of a over the square root of b. So you take the square root of the top number divided by the square root of the bottom number. What does that become?
3/7.
Yep. All right. I don't know why that got thrown in there. It's kind of related. I don't know. It's like that distant cousin, see once every 10 years. Yeah, it doesn't really fit into this, but it is there. So number 7 here, number 7 is all about rationalizing. Okay. You multiply the top and bottom by the square root of 6. So the numerator becomes 4 square root of 6. What does the denominator become? Square root of 6 times the square root of 6. What is that?
Uh, would it just be 6?
It is 6. Yeah, exactly. It's the square root of 36, but that becomes 6. Now you can divide the numbers. So you can take the 4 and divide it by 6 or reduce that fraction. Becomes 2 square root 6 over 3 like that. Is that okay?
Yeah.
Okay, let me know when you're ready for us to move on to 9.
All good.
All right. So number 9 is like a mixture of 7 and 8. We're going to first break this apart by taking the square root of 9 and the square root of 5. What does the numerator become?
3.
3 over square root of 5. So this now looks a lot like 7, where you have to rationalize the top, or I'm sorry, rationalize the bottom by multiplying by square root of 5 top and bottom. So go ahead and work that out. Let me know what you come up with, please.
Three square root of 5/5.
Good. And you can never reduce inside the root. You have to just look on the outside. And this one does not reduce. Any questions before we move on?
No.
Okay, so I want us to do 11 together, and hopefully give you enough information for you to be able to do 10 next. This one's the more difficult one. So you start completing the square by moving that constant to the other side of the equation. X squared plus 8x equals -1. And you've seen me probably for a while now put these boxes here. We have to figure out what goes in those boxes. And it's based on this middle number, that 8 there, that +8. Do you remember what we do first for completing the square with that 8?
Divide it by 2.
Yes. So it becomes x plus 4 squared. And then the number that goes in the box there is 4 squared, or
16.
16. Yeah. And we do that to both sides. It's a sharing. You got to share to both the same value. On the right, this becomes 15. All right, so now this problem looks very much like number 5. Can you look back at 5 and tell me what we did to kind of work this problem out?
Find the square root of both sides.
Yes, square root of x plus 4 squared equals plus or minus the square root of 15. Unlike 5, though, the square root of 15 is not known. So we can't do anything. We can't reduce it. So we just leave it x plus 4 equals plus or minus the square root of 15. We're almost there. Subtract 4 from both sides. Put that up in front. -4 plus or minus the square root of 15. So I'd like you to try 10 now. 10 is easier than 11. It works out nicely. The square root is actually a nice number. Any questions though before you do that? I mean, you said this correctly, divided by 2 square. I mean, it's gonna be the same setup here. Any questions though?
No, I think I got it.
All right, so go ahead and try this and let me know if you have any questions or if you got your answers.
Okay. I got x equals 1 and x equals -11.
Okay, so we'll just quickly check those. 1 squared plus 10 times 1 minus 11. Does that equal 0? And it does. 11 minus 11 equals 0. And the other one that does likely work here, minus 11 squared plus 10 times minus 11 minus 11, 121 minus 110 minus 11, 121 minus 121 equals 0. Very good. Have you been able to do it on the test, start to finish, the completing the square? Is that a yes? I'm sorry, I didn't quite hear.
Yeah, that's a yes.
Okay, cool. Reason I ask is it's hard to do, hard to remember all the steps. Okay, kind of same thing here. I'm going to do 13 with you. I believe it's the one that's more awkward, and then have you try 12 on your own. Solve by using the quadratic formula. Simplify radicals. Okay, quadratic formula. That's the big one here. Minus b plus or minus the square root b squared minus 4ac all over 2a. A is 5, b is minus 5, c is 1. So we talked about the idea that it might be better to do the discriminant first, just to check your calculations, because there's a lot going on here. So let's try that here. B is minus 5 in parentheses squared, minus 4 times 5 times 1. 25 minus 20. Looks like this ends up being 5. Do you agree with that? Minus 5 squared is 25. 4 times 5 times 1 is 20.
Yeah.
Okay, so that's this part under the root. So we go x equals minus a minus b plus or minus the square root of 5 all over 2 times 5. A lot of 5s here. So negative of a negative is positive, so it's 5 plus or minus the square root of 5 over 10. And usually they don't want you to leave it in this form. Usually they don't want you to divide them. So it's 1/2 plus or minus the square root of 5 over 10.
Kind of a weird one.
Yeah, actually, it's really odd that these two denominators don't match up. It's really odd, actually. Like these almost always match, but nevertheless, this looks to be correct. 12 works out nicely. That discriminant is a perfect square, so you'll be able to take the square root of it. I'd like you to try number 12, and if you have questions, please ask, but let me know what you come up with.
All right.
Any questions for me on this one, or?
Um, I think I'm stuck. I got to -7 plus or minus square root of 25 over 6.
Like this?
Yeah.
Okay. This is looking pretty good. B squared, I'll just double check that. So you got 49 minus 24 is 25. This looks great. This is great. So what is the square root of 25?
Oh yeah, 5.
All right, so this is kind of the same as we did before. It is two cases. It's -7 plus 5 divided by 6, and then -7 minus 5 divided by 6.
Okay, I was just making sure that was the next step.
Yeah.
I momentarily forgot where I was supposed to go from there.
So go ahead and finish that off and let me know what you come up with.
-2 and -1/3.
Yes. Fantastic. All right. 14, 15 are very similar. Oh, and that's it. Oh, good. Okay, so so for 14 here, we are going to determine the discriminant. So A equals 1, B equals -7, and C equals 4. A quick side note is that you have to get everything on one side of the equation before you can identify A, B, and C. B squared minus 4AC. Will you calculate that for us, please?
Sure. That'd be 33.
Okay. And notice it's positive 33. Like if you don't put the -7 in parentheses and square it, you get a negative number. You have to put the number in parentheses when you substitute it. So this is correct. And I don't know if we've talked about this, but the discriminant here, there's three possibilities, kind of three broad categories. The first is if the discriminant is greater than 0, if it's positive. That means there are two real solutions. Okay. And that's kind of what it's asking here. Usually though, it asks not just how many there are, it asks whether they're real or not. If the discriminant equals 0, which we've not seen in a while, that's one real solution. It's a repeated root. And then if the discriminant is less than 0, it's two complex solutions. And you can think of these as having I in them.
Uh,
And we can talk about why that is in a moment, but you probably want to get this down if you haven't had this in class in a while. Let me know when we can move on to next one there. Maybe you already are on it.
Got it.
Okay. So for the next one, we're going to do the same thing. We're going to figure out A, B, and C. A is 5, B is 6, C is 4. And I'd like you to calculate the B squared minus 4AC for this one, please.
All right. You got minus 44.
Let me just check here. I thought it was 6 squared minus 4 times 5 times 4. So we get 36 minus 80. So yeah, 44. Good. But negative 44, right? I think you said that.
Yeah.
All right, good. So your discriminant is less than 0. So let me show you what that means. It means that when you're doing minus 6 plus or minus the square root of negative 44, this part is not real. So this is the imaginary part. This whole thing ends up being a complex solution. So whenever you have that negative under there, that's when you get these two complex solutions. And complex refers to what's called the domain. You can think of all the real numbers being here, and then the complex domain is side by side with no overlap. All right. Get some other stuff we can look at here. We got a little time left.
I'll look for something.
Okay.
I sent over um a thing.
Okay. And we'll take a look here. Still waiting. It's stuck in the wire right now. That's a joke. Come on, email. All right, there it is. Great. Got some problems here. Now it's loading. Wheel of death. Spinning, spinning, spinning. Sorry, it's just there it is. Okay. All right. Well, so start with example 4, number 1. Yes. Okay. So we've done a lot of this. This should be very very clear. So quadratic equation is given. They don't set it equal to 0, but you can think of it that way if you want. That's the way we've been doing it. What are the values of A, B, and C here?
A is -3, B is 6, and C is 5.
Good. And then you'll notice this is part of the quadratic formula, minus b over 2a. Kind of interesting. Minus 6 over 2 times -3. What does that become?
1.
Yes. All right. Now we actually should find the y coordinate of the vertex also. I know it doesn't say that, but we need to for the next part of this. So you get that by putting the x value back into the original. Minus 3 times 1 squared plus 6 times 1 plus 5. We're putting 1 into that quadratic equation. Could you simplify that for us, please?
Sure. Eight.
Let's see, -3 plus 6. Okay, hang on here. So it's you're squaring the 1 first. 1 squared is 1 times -3 is -3
Yeah.
plus 6 plus 5. Yes, it is 8. Okay, I was seeing something else. Glad you got that. All right. So the reason you do that, the reason you find your vertex is that goes right in the middle. Well, your instructor even says that. I like that. Put vertex point in the middle of your table. 1, 1, 8. Okay. Now this 5 good points. If you have nice numbers, you always pick 2 smaller, and this is in terms of x, and then 2 larger. So like 2 and 3, 0 and -1. You remember us doing that the other day?
Yeah.
Okay. We also talked about symmetry. Okay, like the fact that you don't have to do all of these, you just have to do the ones that, or you do one and then by symmetry get the other. So will you put 2 into that original equation for x and give me the result, or 0? Either one is fine. Actually, you choose whichever one you prefer. How are you doing on this?
I got 4.
You must have used 2 then, is that right?
Yeah.
Okay, so one of the reasons to use 0 is that it works out a little bit nicer because 0 cancels everything, but this one you're going to square the 2, that's 4, minus 12 plus 5 ends up being 5. And then let me just really quickly do the last one here so you've got it. Minus 3 times 3 squared plus 6 times 3 plus 5. You end up getting 9 times minus 3 minus 27 plus 18 plus 5 ends up being minus 4 here. And that should be enough to be able to answer some of the rest of this here. So unfortunately do have to stop here for today.